Okay, so we can get started.
Hello.
Hey, so hi everybody. Thanks for being here today. With Scott and I, we're going to tell you about building cloud-native applications with containers, functions, and managed services. So first, a little bit about ourselves, Scott.
Yeah, so I'm Scott Coulton. I'm based out of Sydney, Australia. I work in the developer advocacy team for Microsoft and specialize in Kubernetes and container runtimes and all those sorts of things. Been in the Docker Captains project for about 4 years, so probably Phil was the only one that was older than me, and unfortunately he bought Red Hat, so he got kicked out. So now I'm like an OG, an OG sort of Docker Captain. And next is Patrick.
You know Phil cannot joke about that.
Oh, no.
So hi everybody, I'm Patrick Chanezon. I work with Scott in the cloud advocacy team at Microsoft. And before that, I spent 4 years at Docker with Tony that talked just before about BuildKit. So BuildKit, Containerd, I'm a big fan here still. And so my focus is on containers on Azure. So today, we're going to talk about one big topic, which is over the past few years, people have been using Docker and then Kubernetes to build these cloud-native applications. But nowadays, more and more, these applications become more complex. And typically, you're building an application with 3 components, containers, serverless functions that respond to events, and managed cloud services. So in this talk, we're going to try to cover the developer experience for that. How do you package your application when it contains all these components, and how do you make it scale? One of the things I wanted to say is one of the reasons why I was super happy to join Microsoft is that Microsoft's mission is around productivity. So it's about empowering every person and organization on the planet to achieve more. And it started with Bill Gates creating Visual Basic. So it started in developer tools. And so Microsoft always had a strong story around trying to make developers more productive. And I think with the history of cloud-native applications over the past 5 years, now we're getting to a stage where it's really important to start to take a look at how we can make developers more productive. So these 3 abstractions that I talked about, containers, functions triggered by event, and managed cloud services, over the past 3 years, there's been a lot of portable serverless platforms that emerge on top of Kubernetes. So you have things like the FN project by Oracle, which characteristic is that it has a nice way of composing functions. Nucleo, which is super high performance and more suited for intensive data processing. OpenFaaS, which is like the Swiss Army knife of serverless platforms. It can do a lot of things, and it's super easy to use and get started. Galactic Fog and OpenWhisk. More recently, there's been 2 projects that are more like middleware on top of which you can build a function experience, which are Knative and Keda. So we'll talk a little bit about Keda here. And the CNCF has a serverless working group. So these diagrams that show what a portable serverless offering is are coming from their white paper that I highly recommend if you're new to this space. On the Azure side, we have our own first-party service that's called Azure Functions that we manage at Microsoft. But all the runtime for it is open source. So you can run Azure Functions in containers in your own Kubernetes cluster if you want. It's all on GitHub. So that's, so I'm going to talk about the dev experience, and I nuked my slides here, but I'm going to talk through it. It's been the third time we mess it up. The dev experience I wanted to talk to you about is called Azure Dev Spaces, and it's a service that we operate in Azure and that lets you as a developer, and it's tied with a Visual Studio Code extension, so that you as a developer, when you're building an application, You don't need to know anything about Kubernetes. You don't need to have the runtime of the language that you're developing in installed on your machine. You just need to have your source code and VS Code. So I'll show you what it looks like. And the goal of Azure Dev Spaces is to have to make it easier for developers to collaborate together when they're using common services, managed cloud services for their application. So the way the experience works is that you have a VS Code plugin, and there's a command line as well called EasyDS. And that VS Code plugin interacts with a server-side controller that you install in a namespace in your Kubernetes cluster. And so once the connection between the two is established, the VS Code extension is able to prime your project. It looks at your project and it recognizes, oh, this is a Node.js project. I'm going to create a Docker file for it. I'm going to create a Helm chart for it. And I'm going to connect to the server-side controller that sits in your Kubernetes cluster. I'm going to pass all the code to it. And on the server side, we're going to do a Docker build. And actually, I wonder if they're using the new build kit functionality or not. I should talk to the team about that, because there's lots of options there. And then it's deploying it with the Helm chart. And then it opens a connection for debugging. So you're in VS Code. You initialize your project, and then you can start debugging in the cloud right away. And your code can leverage a series of services that are already set up in Azure. And there's an ingress controller in there also that can create URLs. In addition to that, it can create URLs that are public so that your colleagues can test your code in a public way, or it can create a tunnel between you and between your laptop and the code in the cloud. So let me show you what it looks like. So I'm here in there. Let me first. So here. In order to play with Kubernetes, I always use Docker Desktop. So I have my local Kubernetes cluster, which is still starting. And then here in Docker Desktop, I can switch context. And here, I'm going to use a PAT AKS cluster, which is a cluster in Azure that's managed by AKS that I have created. And so I check that my context is right. I'm just going to clear that out. And so I'm just going to do a kubectl get nodes to show you that this is not the one on my laptop. It's the one in AKS that I'm connected to. I opened it, I created it 65 days ago. I hope I won't have any problem with accounting, because I should delete my cluster more often. So then I do a kubectl get namespaces, and you will see that I have installed Azure Dev Spaces in my cluster. So there's one instruction with the Azure command line to do that. Once I've done that, it creates this AZDS namespace, and when I do kubectl get all -n AZDS, so when I look at what's inside of that namespace, you'll see I have a daemon set to pre-pull all the images that I'm going to use, and I have some services for the controller, a service for the controller, tiller that is used for Helm, and then traffic that's used as an ingress controller. So once I've done that, I can start working on my project. So I'm just going to do a code in AZDS Node Web Frontend. So that's a very simple Node.js application, just to show you what the experience looks like as a developer. And so in there, I don't have much. I just have like a Node project, a package.json, and some CSS and JavaScript. So it's and an index.html page. So pretty simple application. I don't have much, and I'm a web developer. I don't know anything about Kubernetes, but I want to start, maybe my application is using some cloud services that I have set up. And so here what I'm doing is that I'm going to go in the command palette, and I'm going to use the extension Azure Dev Spaces prepare configurations files for Azure Dev Spaces. When I click there, it asks me whether I want to have a public endpoint for my application. So in this case, I'm going to click yes. But if it's a really secret application, I could say no. And you can see what's happening there is that here I have a Docker file that appears. No, I haven't installed the extension yet. So I have a Docker file that appears, some configuration for Azure Dev Spaces that I could modify, and then a Helm chart. And in VS Code, I have a launch configuration, which means that I can start debugging my application right away with that launch configuration. So I don't need to set up anything. And if I go in debug mode there, you can see I have a launch server on AZDS. And if I click there, you can see it's launching something. It's executing AZDS up with some port mapping. And what this AZDS up command line is going to do is it's going to connect to Azure, to my AKS cluster, to the controller, AZDS controller on the other side, and it's going to push the code over there or sync my changes in my code, do a Docker build, and this is where there could be some interesting optimization with BuildKit, and then do a Helm deploy of the whole application. And then creates a tunnel between my local machine and the remote endpoint so that I can start debugging right away. And actually, if I go, okay, so I think this is ready. And if I go in the files, if I go in server. Server.js in there. I can put a breakpoint in there. And when I go in my terminal, it tells me that it's available at a public endpoint. So if I go at that public endpoint, I can give that to some of my colleagues. And here, I'm hitting the Azure load balancer that goes inside of my Kubernetes cluster via the ingress controller to that URL. And inside of it, I end up into my application in debug mode. And so here, I can, if I go in the debug view, I can see all my local variables. And I could modify this, for example. I could say, oh, no, actually, I need to modify it there. So I should have created a variable. But basically, I can start debugging my app there. And when I say continue, it's saying hello from web frontend over there. So that's debugging with AZDS. The other experience I wanted to show you, so AZDS, in addition to that, has a few, oh, sorry. In addition to that, has a few interesting features where, with the URLs that it creates for you, you can create different branches so that one developer can have their own version of a certain part of a multi-service app running at a certain URL, while the rest of the developers in the team can use the same other set of services. So it's really for teams to collaborate together on applications that use lots of services in common. Now, there's another developer experience that's really cool that I wanted to show you, which is called LiveShare. So VS Code LiveShare lets you collaborate with someone who has VS Code on their machine. And you can, here, I'm able to give access to the code on my machine, a terminal, and a host on my machine to Scott here, who has nothing from this application, without having him to install anything. And the beauty of it is that LiveShare works really well with AZDS, with Azure Dev Spaces, which means that he'll be able, from his machine, to debug the application that we saw in my Kubernetes cluster without having access to it, just through LiveShare. So we're at 45. Maybe I'll just skip that demo, because I think it's pretty long. I'll add to the slide a link, because I gave that demo at DockerCon, and so you can watch that demo there. Because it takes at least 5 minutes, and we have just 20 minutes more, and there's more stuff I wanted to show you. But just to know that both are working together. And then the third experience I wanted to show you is VS Code Remote extension for containers. So that's something that came out very recently. It's an open source extension for VS Code. And what it's doing is that it lets you create some configuration for your VS Code project so that VS Code is split into two parts. The local part that has the themes and the UI and all the extensions. And then it can run the server part of VS Code with its own set of extensions inside of a Docker container. Which means that, and so you can use that with your local Docker engine. And so what that means is that in your GitHub project, if you set up that VS Code configuration with a Docker file for your project, every developer who's going to join your team when they're doing a Git checkout or a Git clone of the project, they can launch in debug mode in VS Code right away. And all of them will have a similar experience. They don't need to have any runtime installed on their machine. They use Docker, and their code is mounted inside of the Docker container. And so you can customize all these containers, and I'm just going to show you what that looks like. So that VS Code remote extension, that's something that that was announced, I think, a month and a half ago. So it's 6 weeks old. It came out in the regular version of VS Code 2 weeks ago. And in addition to Docker, it can do also SSH and WSL if you're on Windows. So let me close this up, and I'm going to say here, so I'm in VS Code, and I go in the command palette, and I say remote container, open folder in container. So it's going to show me all my folders. And so I have some examples of container-enabled projects in there. I'm going to take one where I have done the build already, so the JavaScript Node 8. So when I open this one, you can see it's installing the dev container, and let's take a look at what it's doing behind the scenes. So behind the scenes, it's taking the Docker file that I have in my project. It's building a Docker image with it, and then it's doing a Docker run with that code base inside of that Docker image. And in that Docker image, there's a VS Code server that's running. So that, and plus it creates a launch.json with a debug configuration for that project, which means I can say I want to launch that program, and it's going to launch this is a Node application again. And then I can ask for a new terminal in there, and the new terminal is going to be inside of the container. So here you can see I have VS Code server running and my Node process. And if I do a curl of localhost on port 3000, so I hit the breakpoint that I had in there inside of my code. So here I'm debugging a Node.js application inside of a container, and I didn't have anything to do to set up all that logistics. So I'm just going to say, yeah, continue, and yeah, so that just works. So that's a remote extension. In terms of development, there's just one more. So these were the two experiences I wanted to show you. Let me go to the right slide. Yeah. In addition to that, when you want to debug either functions or containers in a Kubernetes cluster, there are a bunch of other projects you can take a look at. Squash is one from the Glue team. There's Telepresence, which is a CNCF project. There's Ksync and Tilt, which is pretty recent. I have, if you're looking for my slides for DockerCon, I have a bunch of explanation about how to use all of them. So that covers the developer experience. Now Scott is going to talk about application packaging. How do you package all these applications that have containers, functions, as well as managed cloud services? All right. Oh yeah, sorry.
Can you hear that? Oh, yep. Cool.
Yeah.
All right. So Patrick's done a really good job of showing the application developer persona. But me, myself, am not really much of an application developer. I'm more of an opsy type person. So I'm going to show you CNAB, which is an open specification from both Microsoft and Docker. And also, I believe HashiCorp and Bitnami are now working with it. And what it actually does is it's an abstraction over tools that you already have. So these tools could be Helm, these tools could be Ansible, these tools could be Puppet, it could be anything. And basically what it does is give you a framework to be able to deploy these applications and code that you already have in an abstracted way. This allows you to have your deployment pipelines really, really slimmed down. So instead of having multiple binaries and multiple things like that, you can have just a single way to deploy things. The best thing about CNAB is the invocation image is a container, so you don't need any binaries. You just download the invocation image and away you go. Microsoft has a implementation of CNAB called Porter. What this actually gives you and why you would want to use Porter is we have built things called mixins, and what mixins are is the smarts to talk to a cloud-native API. So if you want to deploy to Kubernetes, you don't need to know anything about Kubernetes except the deployment mechanism that you want. The mixin will look after the smarts for talking to the Kubernetes API for you. Same with Azure, same with Terraform, and also Helm. So if you've already got Helm charts and you want to deploy them and pass different variables through different YAMLs, because you can do that with Porter, then you don't need to know anything about Helm. There's a Helm mix in there for you. So basically you just put the variables that you want into the code and away you go. So it's actually really, really simple. And the good thing about CNAB, whether you use our implementation or you use Docker Apps, which is Docker's implementation, it's not trying to replace any tools that you've got. It's actually working with the tools you've got. And if you build a CNAB correctly, you should be able to use Docker App or Porter. They should be totally interchangeable. The other good thing about CNAB bundles is there's work going on in the OCI at the moment to allow bundles to be pushed to the OCI registry. So what this means is you can actually push your CNAB bundles up with your images, and the application scaffolding will live with the container image, which is really cool. Now, Patrick's application, although it looks like a really simple Node application, it actually has lots and lots of load on it. So he wants performance. And if I don't give him that, then when we do our manager's review, I'll get in trouble. No, that's only a joke. Australian humor though. But basically what we've found with Kubernetes in general, and this is cloud in general, provisioning a VM is slow. So it doesn't matter if you're in Azure or in Alibaba Cloud or any other of the clouds. If you got a node autoscaler, it's going to be like 2 minutes before the Kubernetes node is ready, at least, if not more. So a project was started inside Microsoft and now is in CNCF called Virtual Kubelet. And what that allows you to do is interface to container runtime and make it look like it's a node that's in the cloud. So if you're on Azure, that will be ACI. If you're on Alibaba Cloud, I believe it's EBI. But there's lots out there. If you're on AWS, it would be Fargate. So what this allows you to do is actually scale your pods across vertically without having to wait for a node to spin up. So it'll hit the ACI API, and it will spin up a pod straight away for you. And when you're doing a highly transactional sort of workload, this can save you time and also could save you money. Virtual Kubelet doesn't give you a full node, but it does give you enough that you can get away with a whole heap of stuff. So you can see all the different stuff there. So you get all the normal get pod stuff. And Virtual Kubelet, the open source implementation, there is some limitations to networking coming back into the cluster and bits and pieces like that. If you use the implementation on Azure, we call it virtual node, and we'll set up the CNI provider, and we'll set up a whole heap of networking to speak back to your cluster. So if there's any resources in your cluster that you need to speak back to, you'll be able to do that. Alibaba Cloud has taken it one step further, and they've got a project called Viking, which looks after DNS resolution across their cloud. So at the moment, we do IP across on the CNI. They do DNS. And they also are able to run service mesh across virtual node, which is amazing. Like that was the first time I saw that was in Barcelona. But we need something to look after the scaling, and this is where Keta comes in. So when a HTTP request comes in through Kubernetes, what we want to do is actually scale it. And we want to scale it to virtual node, but we need something to look after that and look at the metrics coming into the cluster and then scale it across to the appropriate place, which is virtual node for us, or virtual kubelet. So Keta looks after that. So Keta can work with a whole heap of technologies to look at metrics. So it can look at RabbitMQ, Prometheus. There's a whole heap of things it can work with. And then what it does is it talks to the horizontal pod autoscaler and then talks to virtual node and scales out that way. So Keta allows you to do a lot of cool things, and it runs both in a standalone method, or it runs also in another method which installs another library by Microsoft, by OpenDAS. Or Deis Labs, sorry, I'll keep saying OpenDAS, it's a habit. It's from Deis Labs, and it's called Osiris. And what Osiris does is allows a zero scale effect on a pod, because on Kubernetes, if you scale a pod to 0 and you have a service endpoint, once traffic goes there, like it gets lost and there's a whole issue there. Osiris is another event component that sits there and allows the service to have no pods beneath it, and then once it needs the pods, Keta will scale them up. So this is what Keta looks like. If you see that external trigger source scaling pods, you've got the Kubernetes etcd store there, you've got the controller and all the parts of Kubernetes, and the horizontal pod autoscaler, so you can see there it's looking after it. So Keta doesn't actually replace the horizontal pod autoscaler, it actually works with it. So what we're going to do now is just run a demo, because it takes a minute. So basically what we're going to do is we're going to use Porter, and we're going to install RabbitMQ via Helm. Then we're going to do a deployment, and I'll go through the deployments, and we're going to install a publisher and a consumer, and we're going to scale it all on virtual node right now with a single command. So we just go Porter, if I can spell, Porter install -c. The -c is passing the credentials file for where my kube control file is, so I can actually speak to Kubernetes. So as you can see there, it's installing the Keta demo. Now I'm going to come back to this because it takes a minute for RabbitMQ to get up, start up. But as you can see now, it's already invoking Helm. So just with a single command, I've invoked Helm, and I'm going to do some Kubernetes deployments. So let's have a look at what those deployments are, and we'll come back and look at the horizontal pod autoscaler. Cool. So as you can see with that CNAB bundle, what we've done is we've installed RabbitMQ. And then what we're going to do is we're going to do a deployment, and it's just a sample deployment. But you'll notice down the bottom here, what we're going to do is we're going to say this deployment right here has a node toleration only to run on virtual kubelet. So that's not going to run on a normal node. It's only going to scale onto virtual kubelet. Now you can see down the bottom there, the virtual kubelet is ACI. If that was Amazon, it would be Fargate or such like that. Then what we're going to do is we're going to use a custom resource definition that Keta uses to have a scaled object. And this will look and see the polling intervals and everything that needs to happen within the RabbitMQ stack. And then we're just going to run the batch job, which is the publish, so we can see things start to scale off. So as you can see there, that was a whole lot of stuff I just deployed with a single command. So like CNAB is pretty awesome. So let's go back. So RabbitMQ still hasn't started. So what I'll do is just go to my other terminals. So as you can see here, we've just got an Azure AKS cluster, but you'll see that there's an extra node there that looks a little bit different. So you can see there that I've got the virtual node running. My cluster is running 114, which is the latest that we can run on Azure, and the virtual kubelet's running there. So the virtual kubelet's acting like a single node, but what it's actually doing is talking to the ACI API, and what it's getting back, it's returning into like calls that Kubernetes knows natively that a node has. So let's go back and hope that. So virtual kubelet, so we've just deployed, as you can see there, RabbitMQ. Now we're deploying the consumer. So if we go over, I killed that. Let's have a look. So that's going to get the horizontal pod autoscaler. And if you have here, so what we can see here is you can see a whole heap of pods terminating. That's okay because they're actually running serverless functions. But you can see there on the node that it's actually only deploying on virtual kubelet. So none of this scaling event that Patrick needed is actually happening on my AKS cluster. So performance of all the other applications I've got running there is actually nothing because I'm offloading all this load, this extra load that's just happened into virtual kubelet, which is awesome. And then if I go back to my scaling, you can see now that I'm starting to get scaling events happen. So you can see I had a 0 replica of the consumer, and that's because I had no traffic. And as we're starting to deploy pods, you can see the replicas are going up depending on the traffic. So before I had HTTP scaled to 0, 0. Now I've got more traffic. I've got 1. I've got 4 coming up now. So as you can see with that single command through CNAB, I've deployed a whole infrastructure looking after a whole scaling event and scaling mechanism, which is quite complex. So let's go back to the slides. The good thing about this particular demo as well is I've open sourced it. If you want the code and you want to run this yourself, there it is. It's all there. It's all in CNAB. All you need is an Azure account because it does need virtual node. If you know virtual kubelet enough and you can get virtual kubelet working on another cloud provider, just take the CNAB bundles and you'll be able to deploy them there. And then there's all these other things that Patrick spoke about. That's where they come. That's where you can get all the different things. And of course, down the bottom, if you want to work for Microsoft, especially in China, we're looking for cloud developer advocates to join mine and Patrick's team. So if you're looking for a new job, you love containers, and you're in China, come and see us after the talk. Any questions?
Okay.
Okay.
If there's no questions, we'll be around outside for questions after this talk. Just a summary of what we presented here. The goal here is when you're developing an application that has containers, functions, and cloud services, there are several extensions in VS Code and in Azure that let you develop that part of that multi-technology application. CNAB and the implementations of CNABs is a specification plus some implementation that lets you deploy these applications. And then KEDA is a pretty good way of scaling these applications, and an open source project that runs into any Kubernetes cluster.
Yep, so CNAB, KEDA, and Virtual Kubelet are not Azure specific. Virtual Kubelet is actually in CNCF. But yeah, you can run them all on Azure as well. And just for bonus, this was actually, those demos were run on WSL2, running a custom kernel. So with VXLAN and support and a whole heap of other stuff that I built on Friday night at an airport, so I'm glad it held up for my demos. And that's all. But thank you very much for coming out to the talk. Thank you.
Thank you.